Hi there, this video is going to be very straightforward. I think the conceptual video did a great job explaining the impulse momentum theorem, and now we're just going to take a look at some practical applications of that. So first of all, impulse, which is defined as the force times the time, is equal to the change in momentum, which is mass times velocity. Now, for all practical purposes, you can really say that the force times time is equal to the mass times the change in speed, because it's hard to imagine changing the mass of something by exerting a force on it. So this is what it really practically comes down to. Delta V means the change from the final to the initial. If you really wanted to expand this out as far as you could, this is what you'd wind up with. One of the things that's important is that you will come across questions where they might say, here's the mass of an object, here's the velocity final and velocity initial of an object, find the impulse. And you say, well, how am I supposed to do that? I don't have the force and I don't have the time. But again, since you have enough information here to find the change in momentum, the change in momentum is equal to the impulse. And so then you can set them equal to each other. Once you find that change of momentum, you have found the impulse. One of the things that can be a little confusing here is units. The units of force is newtons, and the units of time is seconds. Over on the other side, the units for mass are kilograms, and the units for speed are meters per second. So it doesn't look like they're equivalent. But if you recall, force equals mass times acceleration. So a newton really is a kilogram meters per second squared. So if you replace the newtons with that, now we can see that there's an equivalence here, because this second will cancel one of those seconds and you do have the same thing. So sometimes you'll actually hear a physicist refer to a momentum as having the units of Newton seconds. And sometimes you'll hear them say kilograms meters per second. It's the same thing. Now, when you're doing problems, oftentimes you will have all the information except for one thing. And then you just solve this equation for the one thing that you don't know, plug in the rest of the numbers, and you're good to go.